So every day, millions of people ask ChatGPT questions, generates images, write code, and solve problems. It feels like artificial intelligence appeared almost overnight. But here's the surprising truth: AI didn't begin with the ChatGPT. It didn't even begin with computers. The story you're about to hear stretches back hundreds, even thousands of years. It's a story filled with philosophers dreaming about intelligent machines, brilliant mathematicians imagining computers long before electricity existed, a devastating world war that unexpectedly accelerated the computing, and one extraordinary man whose ideas changed history forever. By the end of this video, you will understand why ChatGPT is not the beginning of AI. It's simply the latest chapter in one of the humanity's greatest intellectual journeys. Let's go back to where it all really started. So, when most people hear the word artificial intelligence, they picture ChatGPT or maybe self driving cars or robots that can talk like humans. But history tells us a very different story. The desire to create intelligence outside the human mind is far older than the internet, older than electricity, even older than modern science. For centuries, people asked a fascinating question: can intelligence be created? That single question inspired philosophers, inventors, mathematicians, and eventually computer scientists. What you are seeing on the timeline isn't just the history of technology, it's the evolution of one idea. What was that? Can machines think? And every major breakthrough brought humanity one step closer to answering it. To understand today's AI, we first need to understand humanity's oldest dream. So, long before computers existed, ancient civilizations imagined artificial beings. Greek mythology described mechanical servants built by gods. Across different cultures, stories appeared about statues coming to life, mechanical people, and intelligent creations built by human hands. Of course, these weren't robots, they were myths. But they reveal something important. Humans have always imagined creating intelligence beyond themselves. Centuries later, philosophy transformed imagination into logic. French philosopher Rene Descartes proposed that nature could be understood through mathematical reasoning. Then came one of the history's greatest mathematical minds, Gottfried Wilhelm Leibniz. Leibniz believed that reasoning itself could become a form of calculation. His famous vision was simple but revolutionary. Instead of arguing endlessly, why not calculate the answer? He even imagined a symbolic language that could represent human thought. For the first time, intelligence was no longer just magic or mythology. It became something people believed could eventually be designed, and that idea would inspire the next generation of inventors. So, fast forward to the 1800, a British mathematician named Charles Babbage grew frustrated with human calculation. Mathematical tables were filled with the errors. His solution: build a machine that never made mistakes. He designed something astonishing for its time: the analytical engine. Although it was never completed, its blueprint contained ideas that sound surprisingly modern: a processor, memory, input using pushed cards, and programmable instructions. In other words, the basic architecture of today's computers. But another brilliant mind saw even further. Ada Lovelace. While studying Babbage's machine, she realized something extraordinary. If numbers could represent more than mathematics, then machines might someday manipulate music, images, or even language. She wrote what is widely recognized as the world's first computer algorithm. That's why many historians call Ada Lovelace the world's first computer programmer. The technology wasn't ready, but the vision already existed. The dream of programmable intelligence had taken its first real step. So sometimes history moves forward because of tragedy. World War II became one of those moments. Winning the war depended not only on soldiers but on information. Encrypted messages determined military its strategy, and one machine stood at the center of it all: Enigma. Germany believed its encryption system was impossible to crack. Every day, its settings changed, creating an unimaginable number of possible combinations. And breaking those codes manually would have taken far too long. The Allies needed something faster, something that could search through possibilities at incredible speed. That urgent challenge pushed computing further than anyone had imagined, and leading that effort was a British mathematician whose name would become inseparable from the history of artificial intelligence: Alan Turing. Alan Turing wasn't just trying to build machines. He was asking a question that sounded almost impossible. Can machines think? In 1950, he published one of the most influential papers in computer science, named Computing Machinery and Intelligence. Instead of debating what intelligence actually means, Turing proposed a practical experiment. Imagine having a conversation through text. You don't know whether you are talking to another person or to a machine. If you can't reliably tell the difference, could the machines be considered intelligent? Today we know this idea as the Turing test. It remains one of the most famous concepts in AI history. But at that time, many people dismissed the idea as science fiction. Turing saw something almost no one else could. He believed that machines might one day learn reason and even imitate human conversation. Decades later, millions of people would experience that vision firsthand through systems like ChatGPT. But Turing never lived to see that. His ideas were decades ahead of the technology available in his lifetime. And yet, his question still echoes today. Can machines truly think? Or are they only becoming incredibly good at convincing us they can? In the next chapter, a small summer workshop in 1956 would give this dream its official name: artificial intelligence. So the year is 1956. Imagine walking into a small summer workshop at a Dartmouth College in the United States. There are no powerful computers, no internet, no smartphones, just a handful of ambitious scientists gathered around one bold question: can human intelligence be recreated by a machine? One of them was John McCarthy, a young computer scientist with an idea that would define an entire field. Instead of calling it thinking machines or machine intelligence, he proposed a name: artificial intelligence. For the first time in history, AI wasn't just a philosophical dream, it became an academic discipline. The researchers believed something extraordinary. They predicted that creating a machine as intelligent as a human might take only a few decades. Looking back today, that estimate seems incredibly optimistic. They underestimated just how difficult intelligence really is. Understanding language, recognizing objects, learning from experience, these tasks, which come naturally to humans, turned out to be astonishingly complex for machines. But despite their optimism, the Dartmouth workshop achieved something far more important than they realized. It gave scientists a common mission. From that moment onwards, researchers around the world no longer working on isolated ideas. They were building the future of artificial intelligence together, and soon governments took notice. The late 1950s and 1960s weren't just defined by scientific discovery. They were shaped by one of history's greatest geopolitical rivalries, the Cold War. The United States and the Soviet Union competed for military, technological, and scientific dominance. Every new invention could shift the balance of global power. After the Soviet Union launched Sputnik in 1957, the United States realized that technological leadership had become a matter of national security. Suddenly, research funding poured into universities and laboratories. Computers became faster, programming languages evolved, scientists explored machine translation, robotics, and automated reasoning. Many believed intelligent machines could help analyze military intelligence, plan logistics, or even support strategic decision making. AI was no longer just scientific curiosity, it had become part of a global race. This intense investment accelerated research at an unprecedented pace. Yet, despite the excitement, reality proved far more complicated than the headlines suggested. By the early 1970s, expectations had become enormous. Researchers had promised machines capable of reasoning almost like humans. Investors expected rapid breakthroughs. Governments expected revolutionary technologies. But those breakthroughs never arrived. Computers simply were not powerful enough. Memory was limited, data was scarce, and the algorithms of the time struggled with even basic real world problems. Many early AI systems worked perfectly inside laboratories but failed the moment they faced the complexity of everyday life. Confidence quickly disappeared, funding was cut, research projects were cancelled, media enthusiasm faded almost overnight. This difficult period became known as the AI winter. For many people, it seemed as though artificial intelligence had been little more than an unrealistic dream. Some even believed the field was unfinished forever. But scientific progress rarely follows a straight line. Sometimes the biggest breakthrough happen quietly while almost no one is paying attention. During the AI winter, something important changed. Instead of trying to program every rule by hand, researchers began asking a completely different question. What if computers could learn from experience? Think about how we teach a child. We don't describe every single rule for recognizing a cat. Instead, we show thousands of examples. Eventually, the child recognizes a cat naturally. Researchers wondered whether computers could learn in the same way. This idea became known as machine learning. Rather than explicitly telling a computer what to do, we allow it to discover patterns from data. It was a simple shift in thinking, but it changed everything. As digital information grew, machine learning became increasingly powerful. Every email, every photograph, every search query, every online interaction created more data for computers to learn from. The fuel that AI had been missing for decades was finally becoming available, and then the internet transformed the world. By the early 2000s, the world had become connected. Billions of people were using the internet every day. They searched for information, uploaded photos, watched videos, shared opinions, and without realizing it, generated one of the most valuable resources in modern history: data. At the same time, computer processor became dramatically faster. Graphics processing units, or GPUs, originally designed for video games, proved remarkably effective at training AI models, and cloud computing made enormous computing power available to researchers and companies around the world. For the first time, three critical ingredients came together: massive amounts of data, powerful computing hardware, and decades of machine learning research. It was the perfect combination. The stage was finally set for a breakthrough that researchers had been chasing since 1950s, a breakthrough that could completely reshape artificial intelligence and eventually lead to a system capable of writing, creating art, understanding speech, and holding conversations with millions of people. That breakthrough was called deep learning. For nearly half a century, AI researchers chased a dream that always seemed just out of reach. Then everything changed. Instead of teaching computers thousands of handwritten rules, researchers built systems inspired very loosely by the structure of human brain. These systems called artificial neural networks and existed for the decades, but earlier computers simply were not powerful enough to make them practical. By the early 2010s, that had changed. Powerful GPUs could perform billions of calculations every second. The internet had produced enormous data sets, and researchers discovered better methods for training much deeper neural networks. This became known as deep learning. Rather than telling a computer exactly what to look for, it could gradually discover patterns on its own, show it millions of pictures, and it could learn to recognize gaits, show it thousands of hours of speech, and it could begin understanding human language. The results were astonishingly amazing. For the first time, AI wasn't just following instructions, it was learning from experience at a scale never before possible. And one breakthrough would prove just how powerful this approach could be. In 2012, researchers entered a competition called ImageNet. The challenge sounded simple. Could a computer correctly identify objects in millions of photographs? To humans, this seems effortless. We instantly recognize a dog, a bicycle, or a tree. For computers, it had always been incredibly difficult. Then a deep learning model called AlexNet dramatically outperformed every other competitor. Its error rate was far lower than previous systems. So the researchers around the world immediately took notice. This wasn't just another improvement, it was a turning point. Almost overnight, companies, universities, and governments realized that deep learning worked. Investment surged, research accelerated. Within a few years, deep learning transformed fields far beyond image recognition: medical imaging, speech recognition, language translation, autonomous vehicles, and scientific research. The AI revolution had truly begun, but there was still one challenge left: teaching machines not just to recognize images, but to understand and generate human language. So imagine reading a sentence one word at a time. To understand its meaning, your brain constantly connects each word to ones that came before and often to those that follow. For decades, computers struggled with this. Earlier language models often forgot important context. Long sentences confused them, conversations broke apart. Then in 2017, researchers introduced a new architecture called the transformers. Instead of processing words strictly one after another, the transformers could examine relationships between many words at the same time. This made it dramatically better at understanding context. It could capture meaning more efficiently, learn from much larger data sets, and scale to sizes that previous approaches couldn't achieve. This single breakthrough became the foundation of today's most advanced language models. Without transformers, modern AI assistants simply wouldn't exist. But one company would take this technology and introduce it to the world in a way no one expected. On November 30, 2022, something remarkable happened. A conversational AI called ChatGPT became publicly available. Within days, millions of people tried it. Within months, it became one of the fastest growing consumer applications in history. For the first time, anyone with an internet connection could interact directly with an advanced language model. Students use it to learn, programmers used it to write code, businesses explored new ways to improve productivity, researchers accelerated scientific work, writers brainstormed ideas, and everyday users discovered they could ask complex questions in plain language. To many people, it felt like AI had suddenly appeared. But now you know the truth. ChatGPT wasn't created overnight. It stood on nearly 2 centuries of computing, innovation, 70 years of AI research, and generations of scientists whose work gradually built the foundations for today's technology. The world had finally caught up with Alan Turing's question, but another, even bigger question was beginning to merge. Today, AI is helping doctors analyze medical images, supporting scientists in discovering new materials and medicines, assisting engineers in designing more efficient systems, helping teachers create personalized learning experiences, and enabling businesses to automate tasks that once took hours. But these advances also raise difficult questions. How do we ensure AI is used responsibly? How should societies address bias or errors in AI systems? And what happens to jobs as automation becomes more capable? Who is accountable when AI influences important decisions? These aren't just technical questions, they are ethical, economic, legal, and deeply human. The future of AI won't be shaped by technology alone. It will be shaped by choices we make about how to develop, govern, and use it. History shows us that every major technological revolution brings both extraordinary opportunities and significant responsibilities. Intelligence is no different. So, if there's one lesson from the history of AI, it's this: the technologies that change the world rarely appear overnight. They are built step by step across generations by thousands of people whose ideas build upon one another. From ancient philosophical questions to Charles Babbage's mechanical computer, from Alan Turing's vision to the researchers at Dartmouth, from the setbacks of the AI winter to the breakthroughs of deep learning. Every chapter mattered, and today we are living through the next chapter. The story of artificial intelligence is still being written. The question is no longer whether AI will shape our future, it already is. The real question is how do we want that future to look? I love to hear. I would love to hear your thoughts. Do you think AI will become humanity's greatest tool or its greatest challenge? Share your perspective in the comments below. If you enjoy this journey through the hidden history of AI, don't forget to like the video, subscribe to Upload Decoded, and turn on notifications so you never miss our next deep dive into the stories behind the technologies shaping our world. Until next time, stay curious, keeping questioning, and keep decoding the world around